So yeah, as Nate mentioned, we wanted to go through the type of data that's available and what each of them means. But the reason that we had this exercise before this session is that we wanted everyone to think exactly what sort of information they want to collect before really thinking about what is available, because it's important to know what's really we need, and then we can see what are the data sources that is available and how we can map these two, basically how we can use any of these data sources, a combination of them, to get the information that we just wrote on these boards that we wanted to collect. So the way that I think we proceed with this is that we talk about each data source, how it works, how much data it provides, and what are the pros and cons with it. And then we try to think that if it is really practical for what we want to, the type of information we want to collect or not. And then we move on to the next one. So I think I have slides here. There is a format slides present. Something here for present. I think it's okay. Yeah, this one. Well, I just keep it here. So there are different type of data sources that we saw in the list when we were trying to add the data sources here. If I bring this here, if you go to the design of a study and data source, you can add from the list. And of course, this removes the ones that we already have included. That's why it's a bit shorter, but well, it was a bit longer yesterday, we saw that. So some of these data sources come directly from the hardware, from the phone. Some of them are from what we call it software-based data sources, the data sources that is that some processing has done on the data and then is passed to us. Some of them are basically digital footprints, not necessarily a sensor. For example, your number of calls that you have made, or number of applications and type of the applications that you have used. These are not necessarily sensors. There's no hardware in your phone that measures, for example, number of applications that you have used. That's why we refer to them as digital footprint. Some of these data sources are available inside the phone. Every phone has it, like for example GPS, while some of them are available via peripherals or variables, like for example, if you want to capture heart rate variability or even heart rate, there is no smartphone that is shipped that has that internally. You probably have to capture it from an external device. We talk about why these things matter, especially during the study design. They have direct implications on the burden that will be on the participant, on the cost of the study, and so on. So we talk about them in details. Some of them are Android only. Some of them are available in Android and iOS. This is also something to consider. Some of them are available by default in Ethica. In our system, they have it by default. Some of them are available as an extension. The reason that not all of them are available by default is permissions. You notice that yesterday when we wanted to join a study, it showed a message in the phone to us that that this application requires access to your GPS. Would you allow? Yes, no. The way that the applications work is that whatever you need to access, you have to ask upfront. And you probably also have noticed when you want to install an application on your phone, it tells you that this application requires this, a list of items. And then you either say accept or you don't continue with this. Turned out that if you ask for everything up front, people become really conscious and worried about the privacy concerns of that. So the way that we changed it, we thought that some of the items that are very common, we ask it up front. Like for example, GPS, motion, step counter, and so on, we ask it up front. But some of them that are not as common and are more sensitive, like for example, communicational behavior, how many text messages you have sent or received, how many calls you have received and sent. These are the things that if you would have asked up front, people would be very much concerned that, well, I'm just installing an app that is supposed to ask me about my medication adherence and it wants to access my text messages. Why? I'm not going to do that. That's why we took those out and put it as an extension. So this basically helps with the perceived privacy that participants have. That's why I've mentioned here that some are available by default, some are available as an extension. We talk about those as well. The last thing is that some of these and most of these data sources are collected as episodic sampling. So basically, like for example, something like GPS, the way that we do it is that like every 5 minutes, we collect 1 minute of GPS data. It's not that we continuously collect GPS data. And that becomes important for certain applications. If you really need to have an exact trajectory of people for a certain application, there are different ways to achieve this, while this one, while default way, it's not something that's provided. Some of the other ones are event triggered. Like for example, when we talked about the amount of time that they use their phone, when they turn it on and when they turn it off, this is, we call it event triggered. When the event is happened, we capture just at that moment. For the rest, we don't deal with it. So a bit of a difference between different data sources. I just wanted to go through this. Yeah, and the impact that they have on participants, the most important one is battery consumption. One thing we talk about is the scale of data that each of these data sources produce. It goes anything between 200 records per participant per week to around 30 million per participant per week. So, and this directly impacts how much of their battery gets consumed. So we really need to have an idea that when we say, for example, we want this, for example, we want a step counter versus we want accelerometry data. Step counter produces something around 4,000. Accelerometry data produces something around 30 million. So there are pros and cons with each of them, but this is definitely one thing to consider. The setup and maintenance for them. We had done studies that the setup was actually quite complicated, and that's why participants had to come to the lab and give their phone to the staff, and then the staff had to work on it for 15 minutes to set up our app, then set up Firefox, then set up another plugin for Firefox, then set up another thing, then link all these things. It's, well, we definitely have to consider this, because as we ask people to go through, like basically give their phone to us and allow us to do all sorts of tricks with it, people become a bit uncomfortable. And this also affects the privacy. So this is also something to consider.
Mohammed,
yes.
Can I ask, which sensors are the heaviest battery consumers? Just from thinking about designing a study such that people don't drop out because my smartphone is running out of battery after lunch.
So GPS is the highest battery consumer, but we have done a lot of work on GPS to detect if you are moving or not. If you're not moving, we are not using GPS. If you are moving, we record GPS. That's why, as long as you are just sitting in the office, we don't capture GPS. That's why it saves a bit. It saves battery a lot there. Now, so GPS, because of using this approach, it went lower in the list. And now top in the list are motion sensors. And because of the number of records that we capture, for motion sensors to be useful, you need around 15 to 20 records per second. So when we talk about 1 minute, it's something around 800 to 1,000 records per minute. So you can think about it. It roughly translates to, I have to look at the numbers. I have it somewhere here. I think few million per participant per week. And having that much data encrypted, stored, and transferred requires a lot of battery. So right now, that's top in the list. But we don't need to have motion sensors. When we talk about it, we'll see that you can get step counter or type of activity that they're engaged in, whether it's walking, biking, and so on, and they give you already processed data. Unless you are doing research exactly on the type of motion that they are doing, based on the motion sensor, based on the hardware, which a few groups that we work with right now do that research. Unless you are part of those groups, probably it's not very helpful to use motion sensor data directly. We talk about it.
Motion sensors being
the top one right now.
Gyroscope.
Accelerometer, gyroscope, magnetometer are the ones that there is a hardware chip for that. We'll get to that. This actually literally there's a slide for that as well, which we quickly talk about it. So yeah, the data sources that we will talk about is location, contact pattern, physical activity or motion sensors, we refer to it, survey responses, electronically activated recorder, environmental sensors, communicational behavior, variables, and everything else. So the first one is location, and location is captured in two sources. One is GPS, which is the most obvious one. The other one is Wi-Fi. GPS is available both in Android and iPhone. Wi-Fi is only available in Android. And one thing I have to specify, I have to mention about Wi-Fi is that when I say Wi-Fi and we capture Wi-Fi, it doesn't mean that when you're connected to Wi-Fi, any website you visit and everything is captured. We just capture these routers that are close to you, these access points that you connect for your internet. I think there should be one in this room as well now. Probably they placed it somewhere that I can't see it here, but I'm pretty sure there's one in this room or very close to this room as well. So, where is it? Over there? Oh, okay. Yeah, apparently it's in that corner. I still have problems seeing it. But anyway, there is one definitely close to here. What we collect is that if you probably have noticed, when you go to your phone and say, I want to connect to the internet, it gives you a list of Wi-Fi networks. That's basically, and how strong is that Wi-Fi in form of bars. That's exactly what we record as well. And there are tools that, based on that information, can tell you where you are. Because it turned out that apparently every Wi-Fi has a unique number in the world, and there are companies that know, based on that number, where exactly that Wi-Fi is located. So if you know this information, you can guess where the person is. So this is something that we sample periodically. It can be turned off, as we saw that people can either basically basically don't provide us the permission to access it, that we saw yesterday, or they can turn it off, they can turn their GPS off, then we don't get anything. We use Wi-Fi to basically reduce the battery consumption. I mentioned that we try to guess if you have moved or not, and if you have moved, then we just ask for GPS. We do it through Wi-Fi. The way that it operates is a bit different in Android and iOS. iOS actually continuously collects it versus Android does it a bit slightly different. But at the end, you get the GPS data. We look at it as well right now on the site as well. This GPS captures roughly 80,000 records per week per participant, and Wi-Fi also the same, 81,000 records per week per participant. So. I'm gonna just, to show how that looks like, I'm going to go to one of the sample studies here, maybe study 73. This is a physical activity sample study. If I go to sensor data or raw data, I can select, for example, GPS and user 231. He has more interesting movement pattern than I do, so. So for example, say in May 2017, and I ask, so there are three formats that you can export. You can ask for CSV, and these two formats that you can open with Google Earth. So I'm just gonna ask for KML. If I say go, yeah, it says 12,000 records were collected. So I can download it here. If I open it now, there you go. It unzipped it as well. So this is the file that I downloaded. Okay, where did that go? Okay, you are somewhere in the ocean, in Hawaii. Okay, if I find that.
When was it?
This was in May. I don't know why it should. Okay. Yes, there it is. So basically, if you export it, you can see all the path taken. This is either the hotel, and this is probably the conference. This building.
I got lost.
Yeah, that's. Yeah, but that's basically.
Didn't know where he's going. Even me today.
Yeah, so you can export it for all the sample studies as well. Yes, go ahead.
I thought my iPhone also used cell tower triangulation. Is that part of the GPS function?
Satellite triangulation, that's part of the. So there's a GPS, or assisted GPS, they call it, because GPS itself, assisted GPS uses satellite triangulation as well to improve the accuracy of the GPS. But then on top of that, there is a network location.
Sorry, you said satellite triangulation.
Satellite triangulation, I think, is to use as part of the assisted GPS, correct?
Yeah.
Okay, if I'm not mistaken.
Yeah, I think, and cell tower.
Yes. Yeah, and cell towers. Yeah.
That's the
So
A part.
yeah, that's the assisted part. So the GPS itself, and
Which
then
is why it works indoors.
exactly.
Well, they are.
But indoors, also your map uses Wi-Fi networks as well, because they do have the map of all the access points, and they use your proximity to different access points, different routers. Router and access points are the same, different terminology. So they use your proximity to different access points, and based on that, they do Wi-Fi triangulation. It's a mathematical technique that they use. They call it triangulation because they see how far you are from 3 different access points, and based on that, they can guess roughly where you are located. And that's how it works indoors as well, because Wi-Fi actually GPS does not work indoor by default. So when you are in a big building and still in Google Maps, you see where you are, that's other tools used. It's not GPS. And we do collect those as well, and include it with different tags that shows what sort of data it is. But this is basically data that's exported that you can open it.
Mohammed, if I could just clarify that bit of terminology, because you need to be distinguished between what's called GPS sort of per se, the sort of true GPS versus assisted GPS, which is a broader set of technologies.
Yeah.
That's what's sometimes confusing, because people say, oh, my GPS, I have GPS signal, but what that may be referring to is, in fact, they have a bearing on where they are through the Wi-Fi or through cell tower, and it actually is not GPS satellite. So you have to distinguish between those, and unfortunately, a lot of the times they're lumped into one in terms of popular discourse and kind of casual technology references.
Yeah, and that's basically the data that you saw in the Google Maps. It's just in the raw format. You see that has time in it. It has, like we talked about GPS versus network. GPS versus network. It says which is which. Latitude and longitude. It just has those speed, accuracy. This is, for example, with 56-meter accuracy. It has that, and altitude and bearing. Basically, this is the information for that. So that's the first one. Okay, let me close this. Bring this one up. Okay, so how do you think this can be used for different studies? I believe like this is the this is very tangible. We can see the results of it, how it looks. But one thing I wanted to give a bit time to everyone to think that whether this location data, not necessarily GPS, the Wi-Fi, and so on, but generally location data can be used in different studies. One thing also you have to consider is that you can cross-link that with GIS data. That's why I opened it in Google Earth, because you can see Google Earth already has a lot of satellite imagery included. But you can also cross-check that, cross-link that with the GIS data to get more information on that, similar to the heat map that, for example, Nate demonstrated yesterday through the site.
So, for example, we're linking it to health providers. We can superimpose that map. Is that what you're saying? I was thinking.
Yes, if, for example, health providers, you mean the facilities like clinics, hospitals, and so on. Yeah. So that can be one point, because the GIS data can include the coordinates of all the facilities, right, or health providers, and then you can cross-link that with those information. You can also use some of these in surveys as well. We talked about geofences. The way that geofences work is that you, for example, draw a fence around here, and then you say if they entered inside this fence and they stayed here for more than X minutes, then issue this survey. And that's how geofences basically work for triggering surveys. Or, well, here we, for example, one study that we did in Michigan, they, in Ann Arbor, they did geocoded all the parks and recreational facilities in town, and they created geofence around all of them. Like, for example, this would be one park, this would be another park here, and so on. They did that. There's another one here. They did that with all the parks and recreational facilities in the town, and then they created a geofence around all of them, and when people would enter in the park and would stay in the park for more than 15 minutes, they would receive a survey about that. Same logic here, but instead of park, it can be any other sort of facility that is available.
And similarly, maybe asking why they haven't gone to a certain,
Or if
the
they
Good
haven't.
Food Junction, why they haven't gone to there.
Yeah.
So for planning purposes, I know it changes a little bit, but what accuracy would you say GPS has, just if you think you like, should I use that?
So it can be very different. It gives you anything between 3 meters, 3 meters to 2 kilometers, 3 kilometers accuracy. So what we do is that if we get 5 records with less than 3 meters accuracy, we call it done for that cycle. So we ask for GPS. As soon as we get 5 records, we don't get any more. We just say, well, we already have 5 records with better than 3 meters accuracy, so probably the person is here anyway. So we just stop it, wait for the next cycle. But it can, for the website, anything that we plot on the website, it uses 100 meters accuracy or better. So, but it's up to you how you want to filter the data for that.
So some of those straight lines would not represent the path, but merely 2 locations joined together where there was no measurement between.
Between them, yes, exactly. So if you actually go to the site and use the... Sorry. Sure. About the accuracy?
Yeah, no,
The-
let me show you walking across water.
The
Okay,
straight
right.
line paths.
Right, okay.
Straight line path? Yeah.
Okay.
So yeah, basically the question is that whether there is, when there's a straight line, if it's a jump, if it's a block of time that there's no data available, and I show you how you can check it out. But you are right. When there's a straight line, usually it means that there is a block of time that there's no data available between them. If you come here in geolocation, 231, for example, from temporal go.
Well, I've often wondered, Nate, why you flew to Saskatchewan from Sydney via Europe. So you actually didn't do that. Oh, you did.
You didn't do that. You went through Vancouver, which at that point was probably.
He left his phone in the plane.
Yeah, so one thing so we work a lot with GPS data, and we've done a massive amount of sort of empirical analysis with it, and it's very useful for a variety of things, including sort of measures of predictability of people's movement patterns. But one thing you have to realize about the details of the data is that it's very noisy. And it's noisy both in jittering around a given point like this.
Let me show you that exactly. The jittering is just, you can see it here. So Nate at this time was probably just in the hotel, but see how it changes. He never went to the other street. What is it? I can't read it even. Blackwaddle. Yeah, so he never even went there, but well, it just had some points there. And these are all 100 meters accuracy or higher. So this is already a level of, the data is filtered at least in one level.
Is it possible to cross-reference that jittery, noisy locational data with accelerometry to go, well, actually, the locational data says that you're sort of moving around like this, but the accelerometry says he was different.
There's a lot of ways you can improve the accuracy based on some things. I mean, one of the students in our lab, Winchell, who you know, has done a lot of work to sort of easily filter out outliers, things that are physically impossible, that I, teleport, instantaneously across town or something.
I thought teleporting,
But the the other thing is, there are systematic errors where like sometimes only one satellite's available and it will put you in a well-defined different place, or that the GPS reading fails and it puts you at the 0, 0, 0 position, or it puts you 180 degrees around the world from your current position. And basically there's a lot of machine learning techniques and kind of ways of filtering the data that can allow you to get much better data if you've got the requisite technology friends to sort of work with you to make that.
Yeah.
My follow-up was, is there something which is easily usable and accessible?
There are.
So there are all these noises in that as well. So which, if you want to actually make it very accurate, it's hard, but it doesn't mean that it's not usable. You still can very well guess where he was located, around here, right? And if you have a facility that is like that, it's a relatively big building, especially you can just extend the geofence around it. It doesn't have to be necessarily just as big as the building. You can expand it by maybe 10 meters, 15 meters. That captures 95% of the noise, right? So that gives you a very good idea if the person is in that the facility or not. Yes.
But you can also include logic related to the GPS returns and accuracy.
Yes.
Right. So you can, if your accuracy is 100 meters, and you're saying, I know you are within this place in 100 meters, then that's going to be better than if it says 2 kilometers or more. So
This is one of the fields, yeah, ACCU or accuracy. So you can see it's 87 meters, 50 meters, 56, 21, 8, 12, 9, and it goes down, and every field it has an accuracy that says basically how accurate that is.
And so actually when we did it, we threw away all the records where the accuracy was, I mean, it's not named, it should be inaccuracy, because the higher it is, the more.
Yeah, the higher it is more inaccurate.
The more inaccurate it is, but
It's actually the standard deviation in meters and I think that.
yeah, so what we would do is just choose to cut off like 40 meters, and if it was above 40 meters, then we wouldn't use that signal. But that signal will also tell you something about whether or not you're inside or outside, because if somebody's inside, their accuracy is going to be a much poorer.
Yeah.
It depends on what granularity you're actually looking for, whatever it is you're doing. I assume your heat mapping approach takes some of this into account as well, the variation.
Yeah, the heat mapping thing. So one thing. So back to your question about the straight line, you can see that this is it shows the time here. You can see that 103 it was here, 104 here, and well, you have to trace it all the way. But then you can okay, maybe this is okay.
Was
Probably was your run.
my morning run.
Yes.
Yeah.
That was a very fast run.
Do that again.
Yeah, so 16:21, and exactly this 5-minute block here from 6:16 and then to 6:21, and there's no data in between. So that's why there is one dot here, another dot here. So there's no data in between. So that's why the straight line. Okay, so yes.
Sorry, Mr.
Yeah, sure.
With geographical information data sets, is there a way to plug that sort of raw locational data in and find out things like, and match that up with the known locations of, say, respondent 231 between these times was building 10 at UTS, and then at lunchtime walked north and was at another location. Is there a
I'm not
way
sure if
of-
I understood that.
Is there a way of matching up the latitude and longitude with
Resources.
where things are?
I think
So-
he's asking, yeah,
Where
can you
things are on the
link
map.
it to GIS data, like about where resources are, like you did back.
So there
6 years
are
ago.
a couple of sources available.
So
One
a
is
bit of a lookup table, I guess.
well, but that's a very big lookup table that's available through something called Google Maps programming interface. But there are multiple levels that you can analyze this data. One is through packages like Google Earth. but that's very limited. You can also analyze it through other GIS packages, like ArcGIS is very common. Tableau is something that is also, you can import location data into it. This is something that we will see how it works on. I think it's going to be on Thursday. That we import this data into Tableau, and then you can link this data with survey data, with motion data, with pedometer data, and then see how these different data sources can be linked. What you are asking is something that is available through Google Maps programming interface. Google allows you to basically pass a latitude and longitude and a diameter around it, and returns you all the services of a certain type that you asked for. Like for example, here I can, where was I? Here I can pass this location and say, tell me within the range of 10 meters, what are the services available of this spot? So and how I can do it, the simplest way is to just literally get the data for the past 10 minutes or 1 hour, average it. Just average latitude and longitude for the past 1 hour would give me something around here, and pass it to that to Google Maps, and tells you that, well, around 10 meters around this spot, you can find a hotel, you can find this cafe, you can find this thing as well. And then, or you can just tell me say that, give me all the restaurants within this range, and returns you that. Yes.
But if you've got a huge data set,
Yes.
how much do you want to go in and, it's.
So it's not something
It's
that.
a piece of string, pretty much, isn't it, for how much you're actually going to want to put in to.
So if you have a big data set, you don't do it per person per hour block. You probably design something that can do it automatically for everyone and generate some statistics on that, right? And then you use that as statistics. So that's why I just want to talk about the options that are available to analyze it. So right now we are picking one person and just looking at their data, but you're right. It's for the analysis. Individual data is not very interesting. What's interesting is the aggregate data over that period of time, and that's why it's important to set up that process.
But I would note that in order to do that, often you take the individual data, so that might be, this person's, for each person in the data set, maybe there's, 500 people. For each hour, you cross-link their average location for that hour with particulate measurements for that hour in that location of the city. And then collectively sort of add that up for the participant, which would give a measure of particulate exposure for that person. And then you might relate that to occurrence of asthma as reported by that person, coughing and wheezing occurrences. And so there, for that person, there'd be like it's a risk measurement, essentially, a sort of a risk factor captured in terms of exposure that has been automatically totaled up through this time by linking it in for that participant for where they were during that hour with the particulate measurements and totaling up for them. That's their risk exposure. And then that might be a single number that you use in a logistic regression, or you use it in a survival analysis, or you use it in a recurrent events analysis for when it doesn't explain sort of occurrences of asthmatic behavior or something like that. I don't know if that's helpful, but yeah.
Okay, so
One question.
any other question? Yes, Robert.
How accurate can you be if you want to look at trajectories of movement within a fairly constrained area, such as the emergency department, where you have people sitting in the waiting room, moving to a very, for example, acute or subacute section, or whether moving to X-ray, that sort of, can you detect those trajectories? How accurate is that?
That's a very good question, because I can finish off with answering that question and also lead to the next one. GPS is not the best option there, because as I mentioned, GPS is not something that you can use reliably inside the building. You lose every signal that you receive from GPS inside the building. Then even if you use your maps, it basically uses other options. one of the options that they use is Wi-Fi networks. But the
For example, if I'm using my iPhone,
Mhm.
is the iPhone using different apps to locate it? For example, they can use the iMap
Mhm.
facility and sometimes can use the Google Map.
Yes, so exactly. Your iPhone uses there are different maps that you have. You have probably Apple Map, Google Maps, and so on.
Yes.
But they use some well-known techniques used. One is to use GPS. One is to use assisted GPS, which is basically GPS improved using cell towers, using network triangulation, and so on, and is using Wi-Fi as well. Whether you're using Apple Map or Google Map, they both use these techniques, right? When you're inside the building, you don't have access to GPS, so they mostly rely on the other techniques that they have, and they're not that accurate. That's why you see inside the building, you still see where you are relatively inside the building, but it's not very well presented, especially with respect to levels, right? Many buildings are multiple levels, multiple floors, and those floors are not very well captured with GPS data, because it shows you you're approximately in this area. It doesn't say which floor you are at. You can use Wi-Fi, but Wi-Fi is also can't capture the floor pretty well, because you can be in the second floor and you still can capture Wi-Fi signal from the fourth floor and so on.
And it's also not available.
It's also not available
iPhone.
in iPhone. As I've written here, Wi-Fi is Android only.
So people as on the lift, you cannot detect that because it's a vertical movement.
Yes, yeah. Or even if, for example, I'm here, they don't know if I'm here in the 7th floor or if I'm here on the 8th or 9th floor, which can be a very different room, right? So it's also something. So there, the next one is contact pattern. Like contact pattern, you can think of it as a contact between two individuals, or more abstract than that, as a contact between two of anything. Like, for example, two of anything between me and, for example, this room, between an individual and this room specifically, or between two individuals, or between, as Nate's favorite example, between individual and service dog, or anything else that you can think of. The way that the contact pattern is captured is through something called Bluetooth. It's very similar to Wi-Fi, but it's basically repurposes the Bluetooth technology. You have seen that when you want to connect to Bluetooth, you actually go to your Bluetooth and say, scan what devices are around me. It scans and says these devices are in proximity, and then you pair with one of them, right? With a headphone, for example. It's a very similar thing. So what we do is that we say, every 5 minutes, go scan and find every Bluetooth device around you and write it down. Don't pair with any of them, but just write it down. And that's what it does. And also, Bluetooth also has this number of bars that say how good is the signal. That roughly translates to the distance. So how far you are from someone. So the way that we used to use it was that, for example, everyone's Bluetooth was on and discoverable, and then every 5 minutes, like for example, my phone would say which Bluetooth device is around, and everyone's phone would announce their presence, and my phone would capture it. The same with everyone else's phone, and that's how you would capture my proximity to this team. Bluetooth has the advantage that it's a lot weaker than Wi-Fi signal. That's why it's not very well captured on different floors. You have to be in the same room roughly. If I want to pair with a device that's in another room or another floor, it's not going to work very well. So for this purpose, we use a smartphone's built-in Bluetooth. So you don't need to have anything extra to that. It's just a smartphone's Bluetooth. It's supported only on Android. It's sampled periodically. As I said, that every 5 minutes my phone wakes up and says, well, who else is around? Everyone's phone says, well, we are around, and just writes it down. It can be turned off, just like GPS. You can turn off your Bluetooth. It's very obvious. Accessing Bluetooth is becoming more and more limited due to privacy concerns. This was a viable option. There was no problem with it as of 2015. But it's becoming harder and harder, because there are more and more people, more and more applications that are repurposing Bluetooth for these reasons. And or for reasons that are not very very clear. That's why both Apple stopped allowing using this, and also Android is making it harder and harder. Which I think in version 6 and 7 it was Android 6 and 7 it was hard to get it, but still possible. But there is a promise that they will definitely block it as soon as possible. So it's something to be aware of, and requires both ends to have phones. So if I have a phone, you also have to have a phone. If you don't have a phone, it doesn't detect that.
So a dog, for example.
A dog, if you don't give a smartphone to your dog, it's probably hard to, yes. So and it also captures roughly around 17,000. It's a Bluetooth maximum of 17,000. That depends how many Bluetooth devices are around, but maximum of that number per participant per week. Yes, Keith.
There's a difference between turning off the Bluetooth and being discovered by another Bluetooth device.
Yes.
Interconnecting to it.
Yes.
Am I right?
That's very, very correct. And the way that we do it is that we lock the phone on discoverable mode. But if the people turn it off, we keep messaging them that please turn it on. And as soon as they turn it on, we also turn it discoverable. So this is possible in Android, and we do it. That's how we capture it. But in iOS, it's not possible for applications to access Bluetooth devices in proximity.
So it has to be discoverable to do the.
In iOS, it doesn't matter. It doesn't work. 'Cause in Android, yes. In Android, it has to be discoverable, but it's not something that we ask people to do it. We just set it ourselves that, yeah, make it discoverable. But we still have to ask them that two things. First, allow us to access it. Second, allow us to keep it on. And as long as they accept these two, we can make it discoverable continuously. Yeah.
No, but just on the Apple, they've still got Bluetooth, so they only make it available to the Apple applications, is that right? But not third-party apps. Is that right?
So you mean our system has Bluetooth or Apple has Bluetooth?
On iOS, I think.
iOS still uses it.
Oh yeah, Bluetooth still is available and very well used. It's just that Apple restricts the application to access it. So still, Bluetooth is every phone. All the new iPhones also have Bluetooth available in their phone, and users can use it to pair with different devices and do everything that they usually do. But then, what I mean by becoming more and more restricted is that applications cannot repurpose Bluetooth for this purpose.
In other words, they can't ask who's around on
They
Bluetooth.
can't ask who's around, write it down, and then not to connect with it. They say that if you're an application that you want to use Bluetooth, you have to say why you need it. Like, for example, I want to connect to a Bluetooth scale, or I want to connect to a microphone or a headphone. And then Apple or iOS will do it for you. You can't say, I want to know who's around. It says, well, I don't tell you. That's how it works. Now, the alternative to this, which I think is more would be the answer to the question that Roberto asked, would be using Bluetooth beacons. So the reason that the beacons was created was that they specified that they knew that there is a real need for applications to know their proximity to physical objects, and they call it physical web. So they needed, for example, you go to a store, you walk, and you see, for example, an item. They want, if you, for example, thank you, I will present it as well. So if they wanted that if you get close to, for example, a pair of shoes, your phone pops up and says that, did you know that this shoes is 50% off? Or applications similar to that. In case that you didn't notice it, so they just wanted to make sure that you will purchase that. So they designed something called Bluetooth Low Energy, which is, I already said that Bluetooth is slightly lower energy than Wi-Fi. Bluetooth Low Energy, or BLE, is even lower energy than that. So it has a range of 7 meters to 50 meters maximum, assuming that there is no obstacle. If there's an obstacle, of course, it gets reduced. So if you are in the same room, or if you're in a direct contact, it easily picks it up. It's event-based. What it means is that if so Bluetooth beacons look like this. This is one beacon. I can pass it around. I have 5 of it here. So you can take a look. Oh,
Of the battery life.
these things work for more than a year without charging. And when their battery dies, you have to throw them away.
So these are designed to put on things that you might lose as well? Is that why they've got little pictures on them? Why have they got little
It's their design. I had the fifth
They
one.
come in all different shapes and sizes. Yeah, they come, you can get them in different forms. This is one of them.
Okay, yeah. So there is a link here. I will pass the link around as well. I'm just going to click on this link.
These slides on the.
Yes. So these are so there are two standards. One is called iBeacon, which is from Apple. The other one is Eddystone, which is from Google. And these are the manufacturers, and they support both Apple and Google. And if you just open each of their websites, they have, like the one that I have here is Estimo, which looks like these things. But there are other ones as well.
what sort of cost are they?
They cost anything between, I think, $7 to $12, $13 a piece.
That's all.
Yeah, and they don't need charging, so they work without, they work with their internal battery for a bit more than a year. And
Okay.
yeah, roughly a year. And then when the battery runs out, you have to throw them away and replace them.
And you set up a message that comes from that beacon.
Yes, I explained how these beacons can be used. So you can either just stick them to somewhere, like you can see similar to these Estimo's, or you can wear them like a watch, like the second one. I think this one is, if I'm not mistaken, is from
You're speaking of something, sorry,
Accent.
Yeah, there's adhesives in them, I think, for some of them.
Yes.
You know, stick it on. But maybe not these, but some of them have adhesives that you can peel off and stick on a wall.
Yeah, these ones do have as well. Like you can stick it.
Sticky.
Yeah, it's yeah, you
Is
can
it
stick
like
it.
something that you carry with you, or?
You can, like you can, basically you can purchase these ones and attach it to your keychain, and then you can carry it with you. Or anywhere else, like to
Put it
your,
on a dog's collar.
or anywhere else,
You can
yes.
stick it on a wall to mark a certain notable point. So maybe you want to find if people are washing their hands in a long-term care facility or hospital. And so you have a beacon to mark the location of the washrooms, and maybe you'll time their time in the washroom, and you may ask them a question: did you wash your hands after the use of the washroom?
But,
You know.
Yeah.
but, so, does your phone need to be on Bluetooth discoverable?
No, no.
So,
The
so
works
these things,
for-
they just send messages out, but you don't send messages to it.
So I have to explain how they work. So they are supported both on Android and iOS.
Yeah.
And the way that they work is that they constantly announce their presence within their 7-meter range. And the Android and iOS, the operating system itself, just constantly looks for the presence of these devices. When it finds that they are present, it tells our application, no, that, oh, by the way, you are close to this one. And then I check my records and say, oh, this one is number X, which is located here, so it's this person, or it's this building, or it's this room, or it's this dog, and so on. And then I based on that, I can do whatever I have to do. So that's why it's event triggered, it's event based. It's not, we don't sample. Like the previous one, the Bluetooth doesn't have to be on, it doesn't have to be discoverable or anything. It's just that whenever it's in the proximity of the phone detects that and tells my application that, by the way, you are close to this one, so do whatever you have to do.
In Mohammed, I think like Bluetooth, if I may, that I think the signal strength can give some rough indication of distance.
Yes, there is this is still Bluetooth, but it's not normal Bluetooth. It still has all those features like signal strength that based on that you can guess the distance, you can estimate the distance, but it uses lower energy, which allows them to stay up and running all the time. Because these ones, I think they have a small flat battery, which helps them work for a year. So you can guess how much battery it uses. So it's very low energy.
So if you were, say, measuring the distance between one person and another, there would be a tag on their
Mhm.
and their phone. With Ethica, would they have to break that connection in order to measure a second coming together of those people, or would you poll regularly to see whether they're approximately?
No, so what happens is that, So one thing before I answer your question is that I have to mention that unlike the previous one, in this one, at least one side should have phone, but not necessarily both should have phone. Like for example, in the case of measuring the distance to a service dog, you probably don't need to measure the distance of the dog to person. You can measure person to dog and still you can give you the same information. So the person can have the phone.
Very smart dog,
That's true. And then you can have this with the target, and then whenever they become in proximity, yes, you capture that. You capture the information. This is there are ways that you can capture data without either of side having phones, and these are important because think about the example that I think you asked yesterday about minors and children, or especially infants. If you want to capture infants' distance to their parents, it's unlikely that infants have a phone. So Bluetooth is not going to be the best one. So you probably have to attach for one of these beacons. Actually, there are actually infant-friendly version of this as well. You can search for it. There are those too. If parents have phones with them, this can be captured. But a lot of times parents don't carry phones on them on the phone in the house, right? Probably they just leave the phone in their purse or on the counter and just walk away. So there are cases that you need to capture the distance when neither of sides have a phone. So in that case, usually you can capture these ones with a smartwatch. Like for example, this watch can basically constantly listen for the presence of these beacons, and when they become in proximity, you can just capture that. So you don't need the phone in those scenarios at all. There are limitations there, of course. It's not it doesn't work magically, but these cases are also possible.
So these slides, are they on the?
Yes. Yes. I haven't put them yet. I actually just finished them in the morning, but
So I take it they measure that they're in proximity, and then that triggers off something to happen.
Yes.
From
So
the server.
So if one side has a phone, so I'm going to exclude this one. We can talk about it if you're interested. But if I assume one side has a phone, so this proximity is measured, and as soon as this proximity is captured, then you can say, well, so first you have to go through a few steps. First, you have to see which person or which object this is. Based on the ID that it announces, you can guess. So this says I'm number 1, and you say, oh, number 1 is this room number. So the person is at this room number. And then now you start measuring how long, like for example, you wanted to issue a survey when the person is in this room more than at least 45 minutes. So you start marking their presence in that room at that time, and then you continue it for the 45-minute period, and when the 45-minute period is over, and the presence is reported, you can start issuing the survey. Or you can do anything else that you have to do on the phone.
Do you get any interference if you've got a few of them in a room, or?
No, because each of them are not, well, depends. So they work on different signals, and depends on how many. So I believe there is a level that you will reach a saturation, but I don't know honestly what that number is. But it should be pretty high. Like if you have like 100 of them or so, then you will have a problem. So to trace.
Yeah, and it's worth noting that they would have to be pretty darn close for that
Yes.
to be an issue.
Because they're 7 meters.
The range is so short that by the time you're over across the lobby here, the
You
ones
already
here
don't see this
matter,
anymore.
You know, in terms of interference, they're too far.
Yeah.
I'm just thinking if we stuck them on clinicians or something like that.
Well, yeah, interprofessional collaboration, for example, is one of the reasons we're using. And I think given the reasonable density of people you have, that's not going to be a realistic problem. But, you know, I can work with you to figure out that for sure. But that's what a big investment we're going to be making, is kept tracking teamwork and collaboration and distance from each other.
Or it could be a PE teacher and their students in their class.
Yeah, it could be. And one of the nice things about this for certain types of research, you know, if you have like and forgive me, Mohammed, for just mentioning
No,
this,
please, go ahead.
because there seems to be interest in the service delivery context. We're looking at this a lot for clinic infrastructure and long-term care facilities. And one of the challenges for those facilities are, well, if it comes to long-term care facilities, for example, visitation by loved ones may be important for any number of different studies, including nosocomial infection, et cetera. And the point is that it's hard to get occasional visitors, for example, to a facility to install an app that's gonna trace their contacts with others. But you could ask them to put on a badge, for example, and these things could be in the badge. And I think, in fact, there may be places that sell it as a badge framework. So someone just puts on a badge when they come into the cancer clinic. And in fact, this is what happens right now. And a badge like that can contain one of these, and their movement through the facility will be tracked vis-a-vis the clinicians, vis-a-vis the staff, the people who have the app on their phone. And so you have this kind of tracking of the visitors, could be students in a class, and where they are within a classroom vis-a-vis the teacher, et cetera.
Some predominantly in the region,
That's right, and Mohammed had noted, and you have to talk more about it because I don't know as much about it, but this issue of recording things even without a phone present, you know, a device to device sort of issues. So these open up a lot of possibilities, and they're very cheap, and they're getting cheaper, I think. Over time.
Yeah.
So that, you know, $7 each is something many people can afford.
These ones, I bought them 10 of them for $100. So, yes.
The watch without the phone is interesting. How far along are you with developing the ability to use watches?
So we are right now. We expect that by sometime probably in end of July, early August, we have the beacons. And the one without the watch, without the phone on the watch, there are limitations on that. Like Apple Watch doesn't allow that, but Google smartwatches do allow that. So it's again something that's possible on Android ecosystem to have it without the phone, while for Apple no, because Apple restricts that. But that will be the next step. And we had only honestly one inquiry about that specific case without the phone being present. So it's still unclear that how widely popular this application is.
And if I could note, for some of the groups here, just thinking about their needs,
Yeah.
These technologies become quite relevant even if you're thinking about pill dispensers, for example, and people's encounter with resources at that level. You know, if they're near enough to a pill dispenser for HIV medication, that may be a source for prompting a questionnaire. Or if they haven't been near that for a prolonged time, then it may tell you something about their mobility patterns and access to pills and so on. And so at the level of kind of small scale resources, you know, this could be quite relevant, I think. Yeah.
Yes.
Vehicular environments, you know.
So, would you say you wanted to know where people were and how they were interacting in a room like an ED, would fix the bunch of beacons, a grid of them on the walls and parts of the room, and then use triangulation to get people's absolute location within the room?
Yeah, well, so this, I'm smiling because this reminds me of old memories, because the very, very first version of the study that I was involved was at 2009, and the way that we did it, we tagged 11 locations on campus that was exciting, that it was interesting for us, was cafes, classrooms, and so on. They were not as fancy as these. They looked a lot uglier. And you literally could see the chipset on it, all these ICs and so on. And it was that board, and behind it there were 2 AA batteries that would work for 2 days. And so basically my job as a grad student was to every 2 days go to all these 11 places and just to replace their batteries. So I did it for 3 months. But it worked good. It worked.
Study ran for 3 months.
Yeah, study ran for 3 months.
You encountered the police at one.
Yeah, so they thought it's a bomb or something, because it had a red LED that was blinking, that meant it's working. So yeah, technology has come a long way since then. It looks, yeah. because people would think it's something cool and they would try to take it, and so we had to actually hide it somewhere and the ceiling and so on. So I had to go past midnight when no one was there. So
Not suspicious at all.
not suspicious at all. Yeah. So you would. Yeah, I can go on and tell you stories about that. But so that's exactly what we were doing. And that's exactly how Stealth works as well. So depends on the density that you want. Like for example, if you want to exactly capture the trajectory of people inside the building, you have to put one of these at every corner that they can make a turn, right? So you know that, for example, they walked straight down the hallway, then they turned left, then they turned right, and so on. But if you are looking for the places of interest, that for example, how many times people came to this room, how many times people came to that room, and so on, you can just place these ones at in those rooms, and then as Nate mentioned, you can either ask people to install the application or basically place these things in the badges that people can wear when they enter, and then they can put it out, they can take it out when they want to leave the building, and then you capture all their trajectories or them visiting each of these rooms. So still.
Same thing applies though, I suppose, if you're going to put those on corners, you don't have to put them high enough or, because they look like something that someone else will pick off.
Exactly, yeah. So, yeah, but well, still, you don't have to change their battery every other day. So that's yeah. So that's that's true exactly. So some logistics involved.
And if I could just clarify one thing, there's kind of two very important different models here. One is, and I'm using these as extremes because often you combine them. One is basically the phones are the things circulating, and these things mark particular resources that are fixed. So rooms, you know, the location of a help cart that moves only a little bit, etc. Something along those lines. A bath facility. On the other hand, you also have different models where people or dogs or other highly mobile objects, you know, have badges or have them placed in their collars, what have you, and they circulate around vis-a-vis contact with people that are more or less fixed locations. And so it's patients circulating within a clinic, you know, vis-a-vis the front desk and other places. And the patients aren't carrying the phone, the patients are carrying these things, and their contacts with the clinicians and contacts with the rooms are picked up via phones or something along those lines. That's a model too. And then you get mixed models where, you know, you have some mobile objects with these on here, and you have some fixed objects with them on, and you're just tracking this. But there's a lot of flexibility, and they're cheap enough that you can have quite a few, you know, for affordable prices and reuse them.
Sorry.
So Mohammed, rehashing on that again, the idea of sticking a phone on the wall, is that stupid?
No, it's not. And as Nate explained, that's what exactly one of the solutions. So because you have to see which approach works best for you, because the phones also are not that expensive. You can purchase a phone as cheap as like $100, a brand new Motorola phone, for example, Android phone, which works perfectly. So you can, for example, say, instead of asking every person who comes to this facility to install an application, we give them a badge. That's a lot easier. We only capture it while they're inside the building. We shouldn't be concerned about the very detailed ethics application and so on. But then instead we're gonna buy maybe 20 phones, which cost probably like maybe $2,000 or something, and then place phones at different places. And then these phones constantly listen for the presence of these devices, and when people pass, they have badges, and then we capture whether their trajectory are in part of the building or their visit to certain rooms. But that's totally valid. You probably need to work a bit on a like a box or a frame for the phone, just to hide it somewhere. But this is just some logistics that has to be taken care of. But the technology behind it will be exactly this. So there's nothing different. There's a Bluetooth Low Energy that works on beacons and the phones that capture it, and that's pretty much it. Yes, like.
I was just curious, do there exist beacons where they plug in, so you can just like install and forget?
There are those as well, yeah. So there's this list of the companies that provide iBeacon and Eddystone, these lists, and Eddystone beacons. and any of them that you open, like for example this Estimote, if I click on it, this is their website, that these are the ones that they have. Yeah, so proximity beacons, long range location beacons, stickers, the ones that we showed, and mirror and so on. And each have their, like for example, the location beacons, they work for 5 years without recharging. And it's 200 meters, and this is a maximum 200 meters. You can program the range to be shorter, which then increases the battery life. So if you program it to like 50 meters, then it increases not linearly, but maybe to 6 years, and so on. And it continues. And it says the pricing and so on in the bottom as well.
And what about if they get lost?
If they get what, sorry?
They get lost.
If they get lost, well, you have to replace them. We lost, in our study at 2009, we had 50 of them, we lost 50 of them. So we had 100, we deployed 50.
With this, but that's a very different technology.
Well, that's a very different technology. Actually, no, they didn't get lost. A lot of them got short-circuited and burned. So we had to throw them away. Because you could, as I said, you could see the board there. So if you would touch it the wrong way, you had to throw it away. And they were $200 at least. So yeah, one of them actually just got burned like as soon as I took it out of the package. So it was that fragile.
It's a very different technology.
Yes, this is a very different technology.
Wow, things you would do for research.
Yes.
Changing battery in the bathroom in the middle of the night.
That's true.
That's right.
So, and this is how the data looks like. Basically, you have nodes. This is of course based on Bluetooth, and unfortunately we could not share anything from the real studies that we had. So this is from one of the sample studies, and our sample studies had only 2 participants who barely met in person. So, so that's why
We'll be working with a more interesting data set that's being
That's-
collected as we speak.
That's why we basically added Bluetooth and asked you to update your studies. It doesn't work for an iOS, so if you're using an iPhone, unfortunately, your contact will not be captured. But so if you come to raw data download and select Bluetooth and then select GEXF, which is the format that Gephi tool accepts, and press go, it just gives you a file. We will work with this application later on. It's called Gephi, which visualizes a network. Each of these is one of the participants here. Now, then there is a timeline down here, which if I press play, it basically it basically crashes. It reopen. Well, I give credit to this application. It works better than this. It's probably it knows that I'm demoing it, so it's not very.
I'll be showing it to them again.
Yeah.
Tomorrow or the next one. In fact, we're going to try to get it on people's machines tomorrow or open to it.
Yeah. So maybe I can move on, but we will look at the data later on. But that's how the network is shown. If it opens, maybe I can just load study IJKR. Okay, this is the file. It says it found 2 nodes and 1 edge. Okay, and enable timeline. Reduce it. Basically, it says when there is a contact between them, when there is not. Of course, there is not enough of an information here right now because there's only 2 nodes here. But if there were more nodes, this would be a timeline, and this goes from 2016 to right now, which is something more than probably around 14, 15 months. But well, yeah, if it was more nodes, you could see more here. Okay, so back to the slides. Where is it? Okay. Physical activity is the next one that we talked about. I hope that, well, it's unlikely that we can finish it before lunch, but I hope that we can finish the physical activity one. So it's supported by both Android and iOS. The purpose of it is to, so the way that it was added actually is that there are sensors, there are hardware chipsets that can capture how the phone moves. And moves in the space. Basically, what's the acceleration of this phone as I do this, how it's held, and so on. And that's how they are using this data to capture what we call as physical activity or motion of the phone, which we can relate that to the motion of the person. So the data directly comes from 3 sensors that I mentioned: accelerometer, gyroscope, and magnetometer. I don't go into the details. If you're interested, of course, we can talk about it, but I don't go through the details that what are those information that they provide. But on average, they provide maximum of 6.6 million records a week for all 3 of them, except the magnetometer that's lower, it's 1.8. To be honest, unless you're really into analysis of the sensor raw data, these 3 are not really helpful. They don't help you as much. These 3 are more helpful, and what they give you is linear acceleration, basically how fast a phone accelerates on each of the directions, x-axis, y-axis, and so on. Force of gravity and device orientation, that basically just together, like these 2 combined, tell you how the device is held, whether it's held like this, it's held like this, and so on. One of the most important applications is that when you rotate your phone, this I think iPhone is also the same. With Android, when you rotate your phone, it just shows you portrait versus landscape mode, and also different applications. When you rotate your phone, it shows you different user interface for that. That's how basically they do it. They get data from this, they know how you're holding your phone, and then they change the way that they look. These ones also produce around 3.3 million records a week.
Is linear acceleration X, Y, and Z? So there's 3 of them?
3 of them, yes. And you get
each or 1 million each?
no 3 million, and each record has those 3. Yes. Yeah. So the next one, that what we probably need is actually motion itself, and there are 2 types. That basically this is the result of processing of the data that we just talked about. One is pedometer, number of steps taken. It's fairly accurate. Maybe if you actually walk for 5 steps and look at the data, it doesn't show 5. But if you walk the whole day and then roughly measure how far you have walked and multiply this number of steps that it shows by average step length, those 2 numbers are fairly comparable. So that's how how you can measure it. It's sampled periodically, and you get maximum of 8,000 records, roughly 8,000 records per week. So it's all of a sudden a lot less. And well, you probably don't need accelerometer data anyway. So probably what you need is pedometer or type of activity. Type of activity, or what they call it, activity recognition, is another type that gives you roughly 24,000 records per week. And it tells you whether you are on foot, you're walking, running, on a bike, vehicle, or tilting. That's one of the other states. It's not very accurate, I should say this. This is actually a very hot research topic right now. And even the best algorithms, they also don't work that well. We have one person right now that just dedicated to work on these algorithms to improve it, but it's very, very tricky. So it gives you some, if I have I might have some. So one thing I have to mention is that pedometer already is part of our system. You can, as part of data sources, you can pick pedometer and get that data, but type of activity is not yet. We are still testing it, should be rolled out within a couple of weeks. But how it looks like is this. I can show that as well.
Do you get that data from the hardware thing, the hardware data, or?
We get the hardware data.
Somehow you use the algorithm to work out.
We get the hardware data, then we do 1 level processing on top of that. The hardware is accelerometer, gyroscope, and magnetometer. You do 1 level of processing out of on top of that. You get linear acceleration and device orientation. And then based on those 2, you do 1 more level of processing, and then you get the number of steps taken and the type of activity. Yeah.
Thanks.
And it's not something that I have to emphasize, that it's not something that we do. These algorithms is available through Google Play and Apple, through Android and iOS as well. So the only part that we are working on is on recognizing the type of activity that's taken, that is user is currently engaged in. So I have to increase it a bit. Okay, so read the last one. I want to see how it looks when I talk about it's not very accurate. This is my data when I went for a bit of a walk, and then I stayed, I went to the bank to do some work there, and I came back, pick up my car, and did some driving. It tells 100% with 100% accuracy on walking on foot, 71% unknown on foot, and this is like a. Let me look at the time. This is like every 1 minute it tells me this. It says 20% on vehicle, 69% standing still. And I wasn't on vehicle, so I was standing still. I actually I was walking still. I don't know why it said I'm standing still. I'm standing still, again back to walking. Again walking, and unknown. Doesn't know whether I'm walking, I'm on vehicle, I'm on foot, it's completely confused. And then it goes back to say, well, no, actually, you know what? You're either standing still or in a car. And so, and this thing continues. If you look at it, it says, oh, no, you actually are either standing still or on vehicle, the same thing.
So it's the percentage of accuracy?
The percentage is, like he says, I guess that 69% you're on foot, 68% you're walking, 22% on bicycle. That's the accuracy that they provide. But you see that it's really all over the place. And that is the state-of-the-art algorithm that right now is available. So pedometer works fairly good. This one, not as much. And
Where you have it, you pop it in your bag.
yeah, exactly. And I have to say, the reason that it doesn't work as much is not that the algorithm has a problem, is that with the phone, you can't expect more than that, because you don't know how the phone is placed right now. And the way that these algorithms work is that you have to say that I know the phone is, for example, in the back pocket, now that's how the data looks like. But you don't know. Sometimes in the back pocket, sometimes the user is holding in their hand, sometimes in the purse, sometimes it's sitting on the, like for example, in the car.
Sometimes it's on a ceiling fan.
Yes, sometimes it's on the ceiling fan. While,
I mean, that's without the graphics elements, you have to know that they're either on the waist or on the phone, or they're on the wrist, and there are different algorithms.
yeah, so
Positions.
yeah, that's why the precision that you can get from the smartwatches is a lot higher. It's exactly the same hardware in a smartwatch and in a phone. The difference is that smartwatch is always on people's hand versus the phone is not, right? And that's why you know exactly how to analyze this data, but you don't know how to do it with this data. That's the difference. Sorry, Kate.
Do you know whether the accuracy falls off with older persons who move slowly, as the rest of us that tend to move a bit faster? Well, I'm slowing down for that.
I don't know that. We haven't experimented with that enough to say. Like, we have done a bit, but one study that we are running right now in UK, we actually asked them to use this. So and they are also using Fitbit, so we can get that data and compare it side by side. But this is still like we added pedometer a month ago, and this is the activity recognition is something that we are going to add like within a few weeks. Then I think some time passes, we know a bit more that how the data from these data sources look like. So
can we bring data from wearables into Ethica right now?
that is the last slide that we talk about. Yeah, it is possible, but there are pros and cons for that as well. Okay. So any other questions, points about this? I think the next one is, maybe I can go through Light as well. There was one of the projects that actually had, I remember from the project title, Light was a relevant data source there, whether they are inside or outside. I have to check the project, but, sorry?
So sunlight, vitamin D one.
Yes, yeah, exactly. Sunlight and vitamin D, yeah. So this one can be relevant there. So ambient light is the sensor that you have on your phone. When you are outside, it basically makes the phone a bit brighter. If you are inside, it makes it a bit darker, more dim. It's only available in Android. Captures roughly 1.5 million records per week. And the thing that's important is that you can't use that as an absolute value, as in like a light level of the room, but you can use it as a proxy. Like exactly when the light level changes, especially when you're outside and inside, because the level of light, the illumination of light inside the room and outside, like in the natural light, is very different. Even if you turn on as many lights as possible in a room, you still are in the range of maybe 20 to 30. While if you go outside, all of a sudden it jumps to 300 and above. That's why, especially if it's sunny, so you can capture it there. I plotted this data for 2 days from the sample studies. You can see how it looks like. It's night. It's literally 0. At 7 a.m., there is a bit of a room light here. I think this is a winter day in Saskatoon, which is the days are very short. So at 1 p.m., the person went outside. You can see that. And probably this is still outside, but maybe the phone was in the pocket or something, until probably 2:30. Very likely they were outside because it's the level of light is more than 150. Very likely they're outside. And then sometime for around half an hour, it was again 0, and then it went up again more than 150. And you can see that for the rest, it's lower than 50. This is probably room light. So it's still, there was some light in the room. It wasn't darkness, like for example at night, as it shows here. I'll have to show it with.
So it picked up really well light in the room and light outside.
Yes, the difference the difference between those two is captured pretty well. But well, I'm not sure how useful I can't think of any application on top of my head that you want to know the level of light inside and how bright it is. You want to probably know whether there is any light on or not.
Seasonal affective disorder, maybe?
Yes, or versus whether they're outside or inside, inside the building.
If it's in your pocket, though, like,
If you're outside and it is in the pocket or in
It does
your
not capture.
handbag,
That's not
then-
gonna-
Yeah, if it's in the handbag, it's still not going to capture.
Yeah.
Yeah, but if you take it out, it captures that. That's why you might see gaps here. Like for example, it goes 150, and it goes down again, and it goes like again above 150, and it goes to 0 again. And maybe you can also cross-check that, cross-link that with GPS data.
Yeah.
Does it matter which way up the phone is if it's on a flat surface or if it's on one side or the other?
If you put it like this face down, it doesn't capture any light. Yeah, because the light sensor is actually always on all phones is here. And the reason it's here is just so when you put it here, it just detects and turns off the screen. Yeah. Yes.
This is, we mentioned a little bit the idea of cross-linking between different data, but actually that's probably a really important feature for some of the qualities or characteristics you guys are hoping to measure. And it might not be just GPS in this, it might be GPS and accelerometer in this. You know if it's being carried and the person's moving, then you can say, well, maybe are they inside or the outside? And you can use GPS, not only the GPS signal, but also the error of the GPS signal and the light thing. So there might be some kind of complex analyses that can be done after the fact. If you port it off to do statistical analysis on RSS or something.
Yeah, so we've done a huge amount of data to sort of classify common environments, like are they indoor, outdoor, is the phone even being carried on their person or is it sitting somewhere off their person, are they in a vehicular environment or not, one or two others as well. And those types of classifications, light can play a role, as can many of these other basic sensors, and you can do a pretty good job as part of the deal. Also sitting, standing, lying down, distinguishing those types of kind of still behavior, you can do a very good job. But it's very technical work.
Yeah.
And it is the sort of work, though, that you can then apply in many studies because they're foundational types of classifications.
Yeah, and the data sources that I'm going to talk about from now on, probably by themselves don't offer as much value, unlike, for example, a contact pattern or GPS that by itself is very valuable as well. But they usually can be very helpful for analysis of other data sources, especially when you cross-link them. Like for example, this one clear way to analyze it would be to divide it to 3 states. It's either 0, which means there's no light, or it's some level between, like above 0, above 5, and below 60, 70 level, or above 100. If it's above 100, that's definitely a natural light. An artificial light cannot generate that much illumination. So you can say this is outside. If it's between, if the light still is captured, but between like 4 or 5 and like less than 50, you can say, well, it's probably light, room light. And if it's 0, it's either in the purse or somewhere, or it's well, it's basically just there's no light. Like for example, if it's at night from midnight to 6 a.m., it's 0. Very likely the room is also dark, right? So that's why it doesn't capture any light for 6 hours straight. And then you can cross-link that, these 3 values for every time, cross-link that with GPS, you get more data that what you would have with GPS only.
Can you get low power Bluetooth with light detection built in? As in the same little chips, but with a light sensitive chip?
The beacons?
Yeah.
You mean? I don't think there is any beacons that have light sensor in it. Light sensor is not that big, but I think there is none because.
Do you know where you're putting it?
Well, there's no. Or maybe there is. I honestly haven't gone. I have gone through quite a few of those companies that was listed there, but you have to search a bit more.
The thing is, you might want to monitor whether someone's getting up at night to go to the toilet all the time, because they're at risk of fall. You stick this thing on the wall, they turn their bedside lamp on and they know something's going on, they're moving, etc. Because they're not like they have a phone on them lying in bed, sitting on the
I
dresser.
think wearables are a much more viable solution.
Wearables, yeah.
Yeah. You give them a hex shirt, or you give them a smart band,
Yeah.
and you can track that very well. Yeah. Same thing with sleep quality, same thing with heart rate and heart rate variability, stress, etc. Yeah.
I will stop here because it's past noon, and then we can continue that after lunch. But we can talk about it as long as you have any questions. But I'm not going to talk about the next data sources. There's a few more left, probably maybe another half an hour, 40 minutes that we can talk about it after lunch. Good?